Hello and welcome to another Smithy's Flip Learning. This guide is a step-by-step guide on covalent bonding and dot and cross diagrams. Before we can look at covalent bonding and dot and cross diagrams, I just need to do a quick recap on electron configuration. Now for GCSE we need to primarily worry about the first 20 elements from hydrogen up to calcium. Now the image here is of a calcium atom, and I'm just going to talk you through it because it is very useful for what we're going to look at. Okay, so in the middle here we have the nucleus. The first shell is only able to take 2 electrons. After the 2 it has to go on to the next shell. This shell is able to take the next 8. The shell after is able to take the next 8. Now because we're only concerned with the first 20, the next shell will be 2. Okay, and this lends itself to the 2-8-8-2 rule. So the first shell holds 2 electrons, second shell 8, third shell 8, fourth shell starts filling with 2 electrons. Past that, no, we're not going to worry about that at the moment because it will become more confusing. I've also got here the noble gases. Their inert nature prevents them from forming covalent bonds. So the noble gases, if we have a little look, helium, because it's only got 1 shell, it's actually full with 2 electrons. Neon is full on its outer shell with 8 electrons, and as is argon with 8 electrons. This means they are inert because they haven't got any free electrons to bond with any other elements. Within this as well, if I take a look at hydrogen, its symbol is H, going into an atomic number of 1. Its electron configuration is 1. So hydrogen will come up a lot because it only has 1 electron and it wants to have 2, like the noble gases, to become stable. So that will come really prevalent later on. If I was to take oxygen, oxygen has 8 for its atomic number. So that means it's got 8 protons and 8 electrons. So it's got 2 on its inner shell, its maximum, and 6 on its outer shell. So with 6 on its outer shell, it actually needs to share 2 electrons with another element to become stable. And again, we'll visit that a little bit more later. Now we're going to explore how atoms form covalent bonds using dot and cross diagrams. The slide focuses on hydrogen's simplest atom to illustrate the process. As you can see on the slide, there is a step-by-step guide down the side. This is designed to give you each step at a time to allow you to break down the activity much more simply. So if we're looking at it, first off, you have to find the atomic number of our element and the number of protons and electrons. The previous slide with the electron configuration gives you that information, so you don't have to go looking on the periodic table. You can just look on the table. Okay, as discussed on the table, it has the electron configuration. The particular part you're worried about is how many electrons it has on its outer shell. So in a dot and cross diagram, you only actually draw the outer shell. You don't worry about the inner shells. So with hydrogen, it's only actually got 1 shell. So that's why this one is drawn here. Shared electrons, add 1 dot, 1 cross in overlaps for shared electron. So what that means is this hydrogen molecule has got a circle or a dot. This hydrogen molecule has got a cross, and they're showing how they're sharing them. So if there were additional unshared electrons, they would be added around the outside of the circle. So if hydrogen actually had a couple more electrons, they would be represented but not within the shared part of this Venn diagram type structure. The octet rule is very important. Ensure atoms have full outer shells. So apart from hydrogen, all the other atoms are going to need to have 8 electrons in their outer shell. So you need to check that every time. As you can see here, we've got the 2-8-8-2 rule, which is the amount of electrons in each shell. We've also got the octet rule here. Atoms want to be like noble gases. happy with 8. So they want to get 8 electrons unless they only have the first shell, and then they need to get 2. Okay, so this part of the grid is telling us we've got hydrogen, formula H2. Now the H2, so the hydrogen has 2 molecules because the subscript is saying 2. Okay, we can see that here. So there's 2 that are going to share their electrons to become stable. The formula here, this little line actually represents how many covalent bonds there are. And as there's one line, that means there's one covalent bond, which we can actually see stated right here. So indicating 1 electron in hydrogen, you can see that's written here. So this will be on each of the slides, and it will help you very quickly to understand that the atomic number then goes into the electrons. Now, because there is no second shell, it is only 1 here. Since hydrogen has only 1 electron in its outer shell, it's capable of forming a single shared covalent bond. This characteristic applies to all covalent bonds involving hydrogen. So whenever we have hydrogen, it only ever has 1 bond to share. So it will always share its 1 electron and then share another electron with another substance. So whenever we're looking at hydrogen, you're basically going to see this configuration. Even with bigger molecules, it's still going to be a dot and a cross when hydrogen is involved. Last bit on this slide, circles must be overlapping in dots and cross diagrams. Examiners are very strict with this. If it's just the circles are touching but there's no actual clear overlap, this may cost you marks. So make sure you've got this Venn diagram style with the covalent bonds represented in the middle by dots and crosses. Okay, so now I'm going to go through some worked examples with you to help you understand the principle behind the dot and cross diagrams. First one we have here is oxygen. As you can see at the top, it has an atomic number 8 and its electron structure is 2 and 6. So it has the full inner shell, then it's got 6 on its second shell. Okay, if I look at the information at the bottom, it says oxygen O2. So because there's a 2 on the subscript, we know there's 2 molecules of oxygen. And on the structural formula, there are 2 lines, so we know there are 2 bonds involved. Okay, so 2 covalent bonds. So we know that 2 oxygen are going to share with 2 oxygen to make it stable. Okay, so we're going to take a look. As usual, you would follow the guide down the side to check that you followed the right process. Use the 2-8-8-2 rule, and then remember happy with 8, and that's a check you have to run afterwards to ensure that you've actually balanced it correctly. So here the oxygen moves across, second oxygen moves across. Now if we take a look, we now have 2, 4, 2, so that's 8, and on this side we have 2, 4, 2. This is the double covalent bond because there's 2 sets of dots and crosses. They're within the center area of the Venn diagram style diagram, which means they're the shared electrons. So this example, we are looking at nitrogen. As you can see, nitrogen has an atomic number of 7, so it's in group 7 of the periodic table. It has 2 inner electrons and 5 outer electrons in its electron configuration. The name obviously is nitrogen. The formula is N2. The 2, the little subscript, tells us there are 2 molecules that are going to be sharing here. The structural formula, as it has 3 lines representing bonds, that means there's going to be 3 covalent bonds, which we can see written here as well. Okay, so before we even start, because of the diagram here with the 3 lines, we know there's going to have to be 3 covalent bonds occurring. Okay, so that you can see represented here. If I actually click through, so if we now look at it to check that the octet rule is working, we've got 2 dots on the outside, Crosses in the middle now count as dots. So we've got 3, 4, 5, 6, 7, 8. So this one is filling the octet rule. And on this side, if we take the crosses, 1, 2, this dot is now across 3, 4, 5, 6, 7, 8. So they both fulfill the octet rule with 8 electrons. And this area shows the 3 covalent bonds being shared. So you've got 1, 2, and 3. Okay, here's where you have a go for yourselves. Use the steps that we've already gone through. Just pause the video, and when you're ready for the answer, click play. Okay, so here's the answer for the problem we've just been looking at. We have 17 for its atomic number. We have 287 for its electron configuration. Underneath, if we take a look, obviously got its name chlorine, Cl2 telling us there's 2 molecules, which you were already given the 2 circles. There's 1 covalent bond, so this tells us that there should only be 1 dot and cross in the middle of the Venn diagram. So let's have a look. So now they've joined together, as you can see, we've got 1, 2, 3, 4, 5, 6, 7, 8. If I start here, 1, 2, 3, 4, 5, 6, 7, 8, because these will count towards each other's electron count. Okay, so we can say this fulfills the octet rule of 8. Atoms want to be like noble gases, happy with 8. So they've got 8, so they're happy. Okay, so another one for you to have a go at here. This one is slightly different because we've got hydrogen chloride, which, as you can see, I've broken down for you at the top, which is hydrogen and chlorine. So I'm not going to give you any more information on that. Let's see how you get on with it. Okay, but you have got the information that you need to complete this here. As before, please pause, have a go, and restart the video when you want your answer. Okay, so here's the answer from the previous problem. We have 1 electron in the outer shell of the hydrogen, it's represented here. We have 7 electrons in the outer shell of the chlorine, represented here. If I look at my information at the bottom, it's saying HCl should have 1 covalent bond. Okay, so there should be only 1 dot and cross in the middle. Now it's worth remembering here that hydrogen will always make this dot and cross formation. It can't do more because it's only got 1 electron. So wherever you see hydrogen, it will be making this covalent bond drawing here. Okay, so if we look at the chlorine, 1, 2, 3, 4, 5, 6, 7, 8 is fulfilling the octet rule of 8. So it's happy with its 8 electrons. Okay, slightly more complicated problem here. You've got the same information, you follow exactly the same process as we've been looking at all along. One thing to consider is the structural formula has changed now. So have a look, see if you can work it out. Pause the video until you're ready for the answer. Okay, so here's our answer. Again, let's have a look. Atomic number 1. Oxygen has an atomic number 8, so its outer shell has 6. So we've got 1 and 6. As we've talked about before, hydrogen just has 1, so we know that's got to form the single covalent bond dot and cross. There are 2 hydrogen molecules. So if we look here, we can see that's represented. You've got your oxygen molecule here with 2 hydrogens either side. Okay, so let's have a look to see how you got on. So 1 hydrogen, 2 hydrogen. So we now have hydrogen with 1, 2 electrons. Their first shell is completely full on both cases. The oxygen, whereas it had 6, it now has 1, 2, 3, 4, 5, 6, 7, 8. So it's fulfilling the octet rule with happy with 8. Okay, so here's another problem for you. This one's more tricky. You must look at the formulas at the bottom to work out how many hydrogens there are. Just remember from the previous one how they were set out, and you shouldn't go too far wrong. So have a go, pause the video, have a look at the answers when you're done. Okay, so on this one again, hydrogen atomic number 1, 1 electron in its outer shell. Nitrogen atomic number is 7, 5 electrons in its outer shells. One of the key things here for ammonia is NH3. So we know, because it's H3, 3 subscript, H has to have 3. Okay, so there's going to be 3 hydrogen atoms present to 1 nitrogen. Okay, so you can see that represented here with the 4 different circles. You've got 3 hydrogens, each with their 1 electron, and we've got our nitrogen in the middle with its 5 electrons. As usual, hydrogen is only ever going to make a dot cross single covalent pair, but there's actually 3 of them doing it. So this should result in there being 3 shared electrons with the nitrogen. So that's 1 shared, 2 shared, 3 shared. So if I look at it now, the hydrogens each have 2 electrons, and the nitrogen now has 1, 2, 3, 4, 5, 6, 7, 8. Is fulfilling the octet rule, happy with 8. Okay, this is the last one we're going to take a look at. I've not provided you with any diagrams on this one, so you have to come up with your own. As with all the process node, follow the steps. Make sure you look at the grid at the bottom, particularly the structural formula, to really help you out. Pause the video, have a go, and then press play to check the answer. Okay, so with this one, because we took a look at the formula and the structure, we know there's 4 hydrogens involved. Okay, so if we're looking at the formulas here, hydrogen atomic number 1, electron 1, carbon atomic number 6, so it's got 4 electrons in its outer shell. It needs to gain 4 electrons. Now we know hydrogen will share 1, so if there's 4 hydrogens, there should be 4 electrons shared with each one of carbon's electrons. This should result in our stable shells with 2 electrons for the hydrogens and 8 for the carbon. Let's take a look. So 1 hydrogen pair, 2, 3, 4. All the hydrogens now have 2 electrons, and if we look at the carbon, 1, 2, 3, 4, 5, 6, 7, 8 electrons. So this will now mean it's fulfilling the octet rule with 8 being stable and happy. Okay, hope you found the video useful. Have a go at them yourself, drawing them. It will really help you get them ingrained into your brain. And just remember the information at the bottom, structural formula, very useful in showing you the configuration of your dot and cross diagrams, and ensure that the first element in the formula C in this example is in the middle and the other ones around the outside. Thank you for listening.